Okay, so today we're going to be looking at associate ratios and the value of a ratio. Grab your piece of paper and a pencil. You will be required to do the examples, and you have about 3 problems to complete on your own. So get your materials and let's get started. I can understand the relationship between ratio and fractions. I can describe the fraction a over b associated with the ratio a semicolon b as the value of the ratio a to b. I can understand when given a ratio a semicolon b, different ratios can be formed from the numbers a and b. I can understand the value of a ratio a semicolon b is a over b. I can understand that if 2 ratios are equivalent, the ratios have the same value. I can use the value of a ratio to solve ratio problems in a real-world context, and I can use the value of a ratio to determine whether 2 ratios are equivalent. So looking at example 1, the duration of 2 films are modeled below. A. The ratio of the length of film A to the length of film B is blank. The length of film A is blank of the length of film B. And C. The length of film B is blank of the length of film A. So looking at this, my first tape diagram, first part actually represents A, and the second represents B. So pause the video and try the answer on your own. Let's look at the solution for example 1. So we already said that the first tape diagram of 5 represents A, and the second one of 7 represents B. So A part, the ratio of the length of film A to the length of film B is 5 to 7. B, the length of film A is blank of the length of film The length of film A is blank of the length of film B. So I'm just looking at putting it into a fraction, because this is what I would actually multiply by. So the length of film A is 5/7 of the length of film B. And then C part, the length of film B is blank of the length of film A. I can actually just flip that because it's asking for B first. So I have 7 over 5. So the length of film B is 7/5 of the length of film A. Example 2. A food company that produces peanut butter decides to try a new version of its peanut butter that is extra crunchy, using twice the number of peanut chunks as normal. The company hosts a sampling of its new product at grocery stores and finds that 5 out of every 9 customers prefer the new extra crunchy version. A. Let's make a list of ratios that might be relevant for this situation. 1. The ratio of numbers preferring new extra crunchy to total number surveyed is blank. 2. The ratio of number preferring regular crunchy to total number surveyed is blank. 3. The ratio of number preferring regular crunchy to number preferring new extra crunchy is blank. And 4. The ratio of number preferring new extra crunchy to number preferring regular crunchy is blank. Let's use the values of each ratio to make multiplicative comparisons for each of the ratios we described here. 1. The number preferring new extra crunchy is blank of the total number surveyed. 2. The number preferring regular crunchy is blank of the total number surveyed. 3. The number preferring regular crunchy is blank of those preferring new extra crunchy. And 4. The number preferring new extra crunchy is blank of those preferring regular crunchy. Pause the video until you have answered. Alright, so let's look at the solution. So let's make a list of ratios that might be relevant for this situation. So I can go back and look, and it tells me in my information up here that 5 out of 9 customers prefer the new extra crunchy version. So if I'm looking at this, I actually created a tape diagram to represent the 9, which is all the customers all together. And I'm going to fill in for 5, because I know that the 5 out of the 9 like the extra crunchy. So if I know that 5 out of 9, then that would leave me with 4 that likes just the regular crunchy. So 1, the ratio of numbers preferring new extra crunchy to total number surveyed is, well, I colored in for my extra crunchy, so that gives me 5 to 9. Looking at 2, the ratio of number preferring regular crunchy to the total number surveyed is, well, what is left is that it likes the regular crunchy, so that gives me 4 to 9. The ratio of numbers preferring regular crunchy to the numbers preferring new extra crunchy is, so I'm looking at regular crunchy first, so I have 4 that was regular crunchy, and the new extra crunchy was 5, so I have a 4 to 5 ratio. And then the ratio of numbers preferring new extra crunchy to numbers preferring regular crunchy is, I just have to flip these two because it's asking for extra crunchy first. So I have a 5 to 4 ratio. Let's look at B part. Let's use the value of each ratio to make multiplicative comparisons for each of the ratios we described here. Alright, so in the part we just finished, we knew that there was 9 total. We knew it told us that there was 5 for extra crunchy. So a multiplicative comparison would be 5 over 9. So the number for a new extra crunchy is 5/9 of the total number surveyed. Looking at number 2, the number preferring regular crunchy is blank of the total number surveyed. So if I have 5 with extra crunchy, that would leave me with 4 for regular out of 9. So I'd have 4/9 for regular crunchy is 4/9 of the total number surveyed. And then 3, the number preferring regular crunchy is blank of those preferring new extra crunchy. So I know I had 4 for regular and 5 for extra crunchy. So the number preferring regular crunchy is 4/5 of those preferring new extra crunchy. And then for number 4, the number for a new extra crunchy is blank of those preferring regular. I'm just flipping what I have for number 3. So I get 5/4. The number for a new extra crunchy is 5/4 of those preferring regular crunchy. Moving right along. Example 2, continue part C. If the company is planning to produce 90,000 containers of crunchy peanut butter, how many of these containers should be the new extra crunchy variety? And how many of these containers should be the regular crunchy peanut butter? What would be helpful in solving this problem? Does one of our comparison statements above help us? Answer your own before continuing with this video. So let's look at the solution for this. I've started out by representing with a tape diagram because earlier in the comparisons I had a statement that told me that I had a 5 to 4 ratio of extra crunchy to crunchy. So I had a 5 to 4 ratio. So now in this part it tells me that we're going to have a total of 90,000 containers. And it wants to know how many will have of extra crunchy and how many will have of regular. So if I have 90,000 between both of them, then I can look at my tape diagram, and because I know that 90,000 is for both of them, I know that both of these have to equal 90,000. So then I can add up how many pieces of tape I have for each, which gives me a total of 9. And I can actually divide 90,000 by 9. Nine into 9 goes 1 time. 1 times 9 gives me 9. I subtract. I bring down. 9 into 0 goes 0 times. 0 times 9 is 0. I subtract. I bring down. 9 and 0 again goes 0 times. 0 times 9 is 0. I subtract and bring down. 9 into 0 goes 0 times. 0 times 9 is 0. I subtract and I bring down. So 9 to 0 one more time goes 0 times. 0 times 9 is 0, and now I'm finished. So each piece of tape actually represents 10,000. So if each piece represents 10,000, then I'm able to answer my questions. And my questions was, how many of these containers should be extra crunchy? And how many should be regular crunchy? So now I'm able to look. My extra crunchy was represented by 5, and my regular was represented by 4. So if I get for extra crunchy, I would take my 5 pieces of tape times 10,000 to give me 50,000 for extra crunchy. And if I look at my tape diagram for my regular crunchy, I see I have 4 pieces of tape at 10,000 to get 40,000 for regular crunchy. So I have 50,000 that would be extra crunchy and 40,000 that would be regular crunchy. Have ready for class tomorrow, part D, E, and F of example 2. D. If the company decides to produce 2,000 containers of regular crunchy peanut butter, how many containers of new extra crunchy peanut butter would it produce? If the company decides to produce 10,000 containers of new extra crunchy peanut butter, how many containers of regular crunchy peanut butter would it produce? That's part E. And part F. If the company decides to only produce 3,000 containers of new extra crunchy peanut butter, how many containers of regular crunchy peanut butter would it produce? Just a little hint. You could use some of the comparisons that we did before in the first parts of example 2 to help you to answer these 3 parts. Have them ready for class. Lesson summary. For a ratio A, semicolon B, we are often interested in associated ratio B, semicolon A. Further, if A and B can both be measured in the same unit, we are often interested in the associated ratio A, semicolon, parentheses A plus B, and B, semicolon, parentheses A plus B. For example, if Tom caught 3 fish and Kyle caught 5 fish, we can say the ratio of the number of fish Tom caught to the number of fish Kyle caught is 3 to 5. The ratio of the number of fish Kyle caught to the number of fish Tom caught is 5 to 3. The ratio of the number of fish Tom caught to the total number of fish the 2 boys caught is 3 to 8. The ratio of the number of fish Kyle caught to the total number of fish the 2 boys caught is 5 to 8. For the ratio A to B, where B does not equal 0, the value of the ratio is the quotient A over B. For example, for the ratio 6 to 8, the value of the ratio is 6/8 or 3/4. Have a wonderful evening, and I will see you tomorrow.